Hi everyone, here's another example where we have an application that involves polynomial functions. So we're supposed to use some idea of what the graph looks like combined with some algebra to answer some questions. So this one we get a cost function, that's C of x. So it's a firm's total cost in millions of dollars for producing X thousand units of a good. We also have a revenue function, R of x equals x, and this is supposed to tell us the firm's revenue in millions if they sell X thousand units of a good. So I've given you kind of funny units here. So again, here we're saying we're selling X thousand units, and we're getting C of x $1 million. And the units are the same for the R of x function. So that's what we want to be thinking about. Okay, so actually a little bit of a review question, I think, to start off with. We have this really simple revenue function, R of x equals x. Based on that, we should be able to tell something about the price that the firm is charging for each unit. So kind of a reminder from a little ways back, I think there was some of this in linear. Revenue is price times quantity. So revenue is whatever money the firm is bringing in. So if we're only talking about selling one good, it's however many they sold multiplied by the price per unit. So here, the quantity is our X. So the P is not showing up at all, which means it's a 1. So basically the slope of the revenue function tells you something about the price per unit. So our slope is kind of boring. It's a 1 over 1. But our units are not boring. This is a change in R over change in X, just going back up to what's on what axis here. X is on the horizontal axis, R is on the vertical. So this is $1 million per 1,000 units. So the millions and the thousands make this a little more interesting. So 1 million per 1,000 units. And we get to cross out some zeros, and what we end up with is they're charging $1,000 per unit. Okay, so an interesting slope. Again, not that the number is that exciting, it's just 1, but the units make that kind of an interesting one. Okay, so we're supposed to find an equation for the firm's profit or loss in millions of dollars. So again, just some reminders about some of this financial stuff. Profit is revenue minus cost. So we'll take our revenue function minus our cost function, which is going to equal x minus negative x cubed plus 4x squared minus 2x. Okay, so we can distribute that negative in. We're going to end up, I'm going to rearrange a little, we're going to end up with a positive x cubed. You don't have to write them in descending order, but I always like to. Minus a 4x squared, and then x plus 2x, so plus 3x. So there's our profit function. And we're supposed to decide when they break even, make money, or lose money. So this is the one that I think is finally a question about graphs. So I would try and sketch this thing to answer this question. So let's get it factored. If we want to know when they break even, we're basically asking when P of x equals 0. 0 profit, no loss. So we can factor this thing to help solve that. Factor out an x. And then that does factor even more. So I get an x minus 3, x minus 1. Okay, so without graphing, I can tell from this that they break even if they make 0 or 3,000. Remember your units. So if x equals 0, 3, or 1. Okay, so I'll even list them in order. But remember, the 1 doesn't mean 1 unit. It means 1,000 units. So if they make 0, 1,000, or 3,000 units, they will break even. Okay, so the make money, lose money, there are other ways to figure this out, but I think the graph will do that for us really quick and easily. So if I start trying to sketch this thing, I know that it has intercepts at 0, 1, and 3. And let's see, global behavior, it's a right side up x cubed. So Oh, here, let me actually draw these in, 0, 1, and 3. We're going to start from negative infinity, and then we're going to cross. Notice they're all multiplicity 1, so all of these will be crossed through. Cross, cross. Okay, so I deliberately drew this in really lightly because I don't think negative number of units makes any sense. It's fine to have negative profit, that just means loss, but it's not fine to have a negative x value here. So I really just want to see this. Okay, so that's my profit function. So I've already found the break-even points here, here, and here when profit is 0. So anywhere between 0 and 1,000 units, I'm making a profit. And also anywhere after 3,000 units, I'm making a profit. Anywhere between 1,000 and 2,000 units, I have a loss. I don't know why this might be. Maybe at this point they had to buy a bunch of something, space or equipment to make more, and so they're losing money, whatever it is. But I'm just looking for you to interpret the graph here. So let's see. So they make money. I'll just summarize here. If the x is between 1 and 0 and 1, see if I can read these off, 0 and 1, or if x is greater than 3, man, making a mess here. Okay, they lose money if x is between 1 and 3. There we go. So something like that would be fine if you want to write out in words. They make money if they're producing between 0 and 1,000 units or more than 3,000 units. They lose money if they're making between 1,000 and 3,000 units. That's great. Fine either way. That's what I'm looking for. Thanks for watching.